Welcome to a new episode about Linux system programming in C. Today we will continue our discussion about fork, and I will show you how variables are handled within the child and the parent process, and also how the parent process can wait for the child process to terminate. So let's go. I will copy the example from last time and I will create a new file I will call fork2.c. and let's open it up and let's see what's in here. So basically we have a very simple program. We are printing out starting and then we're calling fork. And fork will duplicate the process, or will create a new process which is a duplicate of the process which called fork. And then the next line here will be executed by two processes. And fork has a return value, and depending on this return value we can determine if an error occurred with fork, if we are in the parent or in the child process. So in case the process ID which was returned by fork, or the integer, is smaller than 0, an error occurred and we only have one process which is running. In case the process ID is equal to 0, we are in the child process, and in case the value is bigger than 0, we are in the parent process. And the value which was returned by fork is basically the process ID of our child process. Okay, so let me modify the program a little bit. So the first thing I will do is I will delete the starting here. I will add a new variable I will call a, and I will set to 1. And now in both processes I will start a small loop. So for the child process, this loop has 10 iterations. And what I'm doing here is I will print out the a variable, and in every loop I will increment a, and then I will sleep for 250 milliseconds by using the uSleep function. And in the parent process I will do the same thing, but here the loop will only last for 5 iterations, and here I will print out parent. Okay, so here the child process will finish after the parent process. So let's see what will happen here. Let me compile the program and let's run it. So now everything is up and running. And the first thing we can see is fork really creates two separate processes with two separate sets of variables, because in the parent and in the child the variable is 1 at the beginning, and if we are incrementing the variable in the child process, it doesn't affect the parent process. So fork is really a completely new process, and a process has its own sets of variables, its own stack, its own heap, and so on and so forth, and the two processes cannot interfere with one another. So for Linux, the two processes are really two separate applications in a way. And the next thing we can see is, so first we are in our shell, then we are starting our parent process. The parent process spawns a child process, but when the parent process is exits, the shell prompt shows up again, because the shell only waits for the parent process to end. But the problem is our shell is available, but the child is still running. And in some cases this is not very good, because normally if the parent terminates, you would expect all its childs to also terminate. So it would be good if we would be able to wait in the parent process for the child process to exit. And there is a function available for doing so, and this function is called waitpid. For being able to use it, we have to include this wait, and here I will create a new variable I will call child state, and down here I will call the function wait process ID. The first argument is the process ID for which we want to wait, and here it's the process ID of our child. The next argument is a pointer in which we can store the exit status of our child, and the last argument are some optional options. For example, if we just want to check if the child has exited, but we don't want to wait for it, there would be a flag available. But I will show you this just in a second. So here let me open up the MAM page for waitpid so we can see the arguments again. So here we have our 3 arguments. The first one is the process ID for which we want to wait, then a pointer in which we can store the exit information about the child, but we can also pass null here if we're not interested in this, and some options. And let's see which options are available. So yeah, waitpid also has a return value. So 0 means wait for any child process is equal loop. So 0 means it exited with success, else we get an error code. And here we can see the options. For example, if you would use the options W no hang, it will return immediately and not wait for the child to exit, for example. And if you're interested in how to use the child status, in this integer various things are contained. And there are macros available to get back the information. So for example, with wi if exited, we can see if the child has terminated normally or by returning from main. So yeah, for example, with wexit status, we can see the return value of our child. And I think this is something we might want to print out in our simple program here. So here I will printf child exited with return value. And here I will print out the return value. Then I will use the macro here. So let's copy this. Child state. And then we should get back the return value. But the return value here should be 0 unless we are using return 42 here, for example. So yeah, now let's see how this program behaves. Let's compile it and let's run it. So now parent and child is running. So the parent is waiting for the child to exit, but the parent has left the loop, and then after the child has terminated, the parent will also terminate, and here we can see the return value of the child was indeed 42. Okay, cool. So yeah, these were some more information about fork and how to wait for processes. I hope you've enjoyed the video and learned something. In case you want to support my work, you can buy me a coffee on buymeacoffee.com/for Linux. So thanks for watching and goodbye.